Hello again. Welcome to Barbara YouTube channel. This time I have something really exciting. I'm actually excited about it. I'm going to be breadboarding this MXR Distortion Plus pedal, and it's truly one of those famous ones. Lots of 70s and 80s rock, heavy metal. Lots of albums were recorded with this, likes of Dave Murray from Iron Maiden or Randy Rhoads from Ozzy Osbourne. They use this pedal a lot, and I'm kind of liking the sound of it. So what I'm going to do, I have everything pre-prepared. I'm just going to get into breadboarding it. I have some other stuff ready to give it a try. Different types of clipping, whatnot. But what I'm essentially going to do is I'm just going to go through this, get the sound, see how it sounds, try out some different clipping options before I go start with this breadboarding. I don't have 50k audio pot. I have 100k. Won't make any difference in this circuit. Now look at this. I have this beautiful Borns pot, anti-log 500k. Something similar I used in MXR microamp. I just thought to brag about it. It looks nice, huh? Anyway, let me get started and we'll get through lots today. Okay, let me just move this to the side. It's good to be prepared. Makes things easier. Let's get going. Okay, that looks done. What a mess of cables, huh? Let me just get this out of the way. Let us try it out. It would be very embarrassing if this did not work from first, because I tried this out before. Practiced. The key in getting better, I suppose, with everything in life is practice. Okay. Let's plug this in. And all I need in the end is to plug in battery. Oh yeah, I forgot to turn on my amp. Okay. And the moment of truth. Let's see if this works. Yeah. Actually, it's bypassed. Yeah, it's working. So, as you expect, we have volume here. Can't hear anything. And as you increase, volume goes up significantly. So I'm just gonna roll it off a bit. I'm in my small room. I want to survive this. I have here distortion 1. I'm just gonna go all the way down and see. It should be pretty clean now. No. Very, very little difference between bypassed and as I increase the gain, you'll see it's gonna slowly become. It's working like a booster nearly, but very shortly. Let's see. Do this bit. And there is a slight difference as you increase gain. Now let me do that bit more. Yeah. And you can already hear a slight clipping there. Nice. Let me increase this a bit more. I could go on with this, huh? Nice compression. Yeah, it goes. It kind of clips very quickly. It goes into very hard clipping, so. Okay. This is maximum here. I just rolled it down. Yay! It sounds great. And hopefully if I mix this correctly while I was doing all the breadboarding, you heard some of the some sample of sound. Pretty much my amp currently is all EQ is at noon, bass, middle, treble, all at noon. So let's see what next I can do here, because I mentioned on the website we can do something like this, you know, this clipping. Oh, let me turn it around and turn off the amp for a second. So you see here, there are various options, you know, that we can do. First of all, I'm using silicon diodes, originally used germanium. It clips sooner than silicon ones. Silicon ones clip, everybody says 0.7 volts, but like that's not really true. It depends on the current. Current is very low, so this would clip at sooner, 0.4, 5, 6, 7, I don't know. Depends on the diode, but like most of them are probably same. So I prepared a few here, different things. I'll come to the capacitors later on. But here I have some LEDs. I have one of the Schottky diodes, just for fun of it. I can do some kind of, this is symmetric clipping. I can do asymmetric clipping, see how that sounds. Let's give it a try. I'll add LED, get some asymmetric clipping, you know, go to the website. There's a few more options, you know. These are the options. You can try different things, you know. It's kind of I have red diodes. You can try orange, blue, whatever. But let's give it a try. This is gonna get fiddly a bit. Okay. Things are cramped, lots of wires. Let me turn this right way around. I think this is the way. So what I'm expecting really is, because this red diode will start cutting off at around 2 volts. That's quite hotter output than what you get with the silicon diode, so I might need to roll off some of the volume, but let's hear it. Okay, turn this on. Ooh, my DI is clipping, so let me just roll this off a bit. It's quite loud. Ooh, and it's quite a huge difference. You won't see much of a if I did really loud and played really hard. You might see even this diode lighting up. Yeah, but that won't happen here. So it's quite loud, and this is asymmetric clipping. So let me put both LEDs. See if I can spot any difference. Let me do this. Okay, turn off the amp. Get out. That is gonna get a bit tricky now, getting it all out. Look. This goes here. Yeah, I don't know which way I turn them around. Okay. So longer lead up, longer lead down. That should be right now. Let's give it a go. Oh, this is too loud. I have to roll this off a bit more. This is really loud. Okay, what did we learn here? LEDs are really loud. Now, clipping should be softer, clipping, but they're really loud. Let me try on Schottky diode, and then let's see here. Okay, plugged it in. One. Okay, how do I do this now? Okay, go in there. Hey, I managed somehow. Okay, let's hear it. It's way... Okay, it's not as loud, so let me just give it a bit more kick. Yeah, and as expected, like it does clip very quickly. Something like 0.3 or something like that, comparable to where germanium diodes clip, but I'd say they probably have different sound. I have no germanium diodes here, so like it still sounds good. Okay, a lot to go through. Let me do another try with asymmetric clipping with two silicon diodes on one end. Let's see how am I going to do that. Let me do it like this, I suppose. Just do it like this. Okay. Just need to get polarity right. Should be slightly louder. No. Just stop slotting it in. If I wasn't recording, probably done it differently. Anyway, there it is. Okay. Checking the orientation. Should be good. Okay, let's give it a try. Yeah, definitely louder, right? Hey, there you have it. Lots of different options. Hours of fun, I'd say. Yeah, definitely. Yeah, so let me go to another thing. Actually, let me get back to this single kind of a one diode configuration. So let me just get back that in. I just turn this around. It was correct polarity because I was doing this way with two diodes. Let me get this sorted out here so I don't lose all these components. So okay, for an added bonus, okay, what I'm going to do is I'm gonna actually add diode 250 overdrive preamp. Has nearly identical circuit as MXR Distortion Plus. And it's interesting because if you look at it and, you know, yeah, I guess you won't be able to see the difference if I don't show them side by side, but hopefully I'll remember to put it on screen when I mix this. So when I added this, so the only real difference here is this C1 capacitor. Okay, and this is 120 picofarad capacitor, and what it does is MXR Distortion Plus has a hump around 1.5 kilohertz or something like that, where it maxes, where it has maximum gain. But by adding this capacitor here, what's happening is this hump is brought forward. It has the pedal has a slightly less gain, but the hump happens around 800 hertz or something like that, more closer to probably what a tube screamer has. So the only real difference here is this one capacitor. Everything else, the topology is the same. I know in the circuit the you see on the circuit this is MXR Distortion Plus, but on diode 250 this capacitor here is 4.7 microfarads, which makes no difference to the output, to the frequency response. These resistors are slightly different values, but they just provide reference value. Makes really no difference. This one is decoupling capacitor, makes no difference to the sound. So all in all, really the circuits are pretty identical. So you know what? For the price of one, you get two. If I just put some capacitors here, and I just bypass this resistor here. Well, I say bypass. It's not really. It creates a filter there, but what it does is it kind of attenuates some of the higher frequencies. So let me. I have the original 120 picofarad, whatever was in the original pedal. So let me add it there and see if we can notice any difference. Come on, man. That's it. That's all it takes. So yeah, you can tell the difference, I guess. So what I'm going to do is I'm gonna rewire this real quick. So I add a little toggle switch. I could use just on-off switch. So what I'm going to do is I'm just gonna organize this so like this. So lots of wires, apologies for that. Let me move this a bit. Okay, that wasn't so bad. So what I'm going to do is I'm gonna put this switch in between here so I can turn it on and off and you can hear the difference. Okay. These clips are great if you don't want to solder anything, but they're a bit, they make cable hell out of this here. Let me just see if I can somehow get this in so I can actually manage it and even show what's happening. Okay, so I'm just gonna plug it in here. I hope this makes sense. So when I toggle the switch, in this position, the capacitor is in the circuit. When I toggle the switch, it's out of the circuit. It's kind of a, there's these 2 points are disconnected, so the capacitor makes no difference. So capacitor is off. We are talking about MXR distortion. Let me see if I don't, let me not short these. Okay. Okay. Let's see. Can we spot the difference? Yay. I can't actually spot it. Okay, so this is currently diode, let's call it diode circuit. So what I'm going to do, first of all, it affects the output of kind of higher frequencies. I wouldn't call them mids, I don't know, but the guitar has a range, so at least the base frequency of tones is kind of from something 80 to 1.23 kilohertz if you don't take into account harmonics. So obviously harmonics are very important. They give this sound to the guitar, so it doesn't sound like something else, I suppose. So there are higher order harmonics that will be affected by this, obviously. So let me try playing something a bit higher. Yeah, it's all connected. MXR. Diode. There should be some difference if I connected this correctly. Okay, maybe if I switch this and I put a different, if I put a bigger value for capacitors. What is this? This is 270 picofarads. More of the higher frequencies will be rolled off. So okay, go in there. So let's hear it. So without the capacitor. And I can definitely hear it with a higher value capacitor, and you know, it kind of sounds brighter. MXR sounds brighter with that. But if I go back, you know, to a more something that is more kind of closer to what diode would be with a more common value for a capacitor of 100 picofarads, I was struggling to find that 120, to be honest. So, okay, let's hear it. So, MXR, right. Not as bright, should be. Okay, so that's really it. You get, if I was doing the, you know, pedal, I just add this switch and I have kind of a two sort of voicings. It's not a huge difference, but there is definitely some difference in it. So the last thing I wanted to do was rewire this. So first of all, let me get rid of this. Okay, so the next thing I'm gonna do is I'm going to I don't have too many of these LM741 op amps. I have more of these TL 072. I have a full drawer of them, so I'd say, let me see how that sounds, and better I'm gonna just use LM741 for experimenting with, you know, or let's say original op amp, rather than, you know, using TL 072. So if you wanted to change, say for example, to replace LM741, you don't have it, you could just use TL071. Just drop in replacement. TL071, 061, whatever you have. If you have something like TL072, again, the circuit will work. We'll see what's the difference in sound, you know. But the circuit will work. What the difference will be for TL071, no difference in the circuit, you just plug it in. But with TL072, you see there is a slight difference in pinout. You see this, it has two op amps in the package, so you can just plug it in straight in, even though it has 8 pins. The pinout is different. So for example, this positive supply is pin 8. On LM741 it's pin 7, so that's a different thing. 2, 3, and 4 are the same. Differential inputs of the op amp plus negative supply, which we put to ground, but this output of the op amp is pin 6 on LM741. It's pin 1 on TL072. So that requires a bit of a different wiring. Let me find my wiring diagram. So yeah, I kept the components in the same place, so but I had to move this C4 slightly here, and I wired them up. Pin 1, you see here, and it's wired up here instead of pin 6 here. So very little difference. Let me just rewire it and we'll hear how it sounds. There it is. Horror of anti-static protection. You shouldn't be really doing this with chips like this. Like what I'm doing, probably proper anti-static precautions should be, taken. But the op-amp is pretty sturdy. The TL072. I'm sure it will survive my abuse. So let's hear. I hope I got everything right. Let's see how that sounds. Where's my pick? Oh, there. Okay. It's working now. It is a bit brighter, I'd say, than LM741, but there are ways to deal with that. So we can have a look. What I'm going to do is, because obviously you can't hear this very well, I'm just gonna do 1 or 2 kind of just tunes or whatever, chord progressions, and I'll mix them or edit them so they appear one after the other, and I'm just gonna vary the MXR Distortion Plus with LM741, with TL072, and with diode 250 version, and hopefully we hear some difference.